Alright, the next topic which we are about to see is impulse. That is related to this one. So next topic you can write impulse. So see here, now the word impulse is used to denote a situation where a strong force acts for a short span of time. This is the usual procedure. Okay, when a strong force acts for a short span of time, then usually we use the word impulse. However, the time duration can be longer, but usually it should be small. The best example is a cricket ball. Okay, a cricket ball is hit with a bat. The period of contact between the ball and bat is very small, maybe a fraction of a second. And the bat gives a huge blow to the ball. So a strong force acting for a small time. Similarly, when we were small, when we didn't used to finish homework, teacher's hand and our cheek. Teacher's hand and our cheek. Period of contact was very small. I still remember when we were in class 9th, I remember. Class 9. Our physics teacher went away, disappeared. So it was free period. So we were waiting. For several days the period was free. So we used to enjoy shouting, and because indiscipline, class will remain indisciplined in the absence of teacher. Then so we were doing some naughty things, laughing and enjoying. Suddenly a teacher, some person came on this platform, and apparently he was from Hindi medium, because when a person whose schooling is in Hindi, if he speaks English, you can easily know about him, because the way he pronounces, the way he speaks, you'll understand that he is from Hindi medium. So probably the teacher was from Hindi medium, and he told, no discipline, no manners, no discipline, no manners. We were not knowing he was teacher. We didn't see him. So he was standing here, we thought maybe some person is there. So we did not stand and greet him. So that's why he was asking, no manners. Then immediately we understood that maybe he's a teacher. So all of you, we stood and, good morning, sir. So the way all of us did good morning, sir, one Sardarji was there. You know Sardarji, Pagdi, he has a turban. So he was laughing, because jokingly we told, good morning, sir. So he was laughing actually. So he asked everybody to sit. All of us were sitting. The Sardarji was laughing and sitting. He came there. He came close to the Sardarji. And then suddenly we came to hear a huge blow of sound, and then the Sardarji was doing like this. We did not see the hand of the sir. When the hand went to his cheeks and when it came back. It was within a fraction of a second. Sardarji was doing like this. We could only hear the sound. Later we came to know that he was laughing, and so he got that. So that was an impulse. In day-to-day language also we use the word impulsive decisions. When somebody takes quick decisions, we call it as impulsive decisions. Quick and strong decisions. Strong decisions taken in a small time interval are impulsive decisions. So a strong force acting for a small time. So if that be the case, time interval is small, then the impulse is measured by the effect the force produces. So the effect produced by the force is calculated in terms of the product of force and time interval for which it acted. So suppose F force acts for a time interval delta t, then you just have to use the product to get the impulse. Remember, force is a vector quantity, Time interval is a scalar quantity. When you multiply a vector with a scalar, again you get a vector. And if the scalar is a positive scalar, then you get vector in the same direction as the old vector. So impulse direction will be same as the force vector. It is just a multiplication, F into delta T. So what about the SI unit? SI unit will be Newton meter. Force, sorry, Newton second. I'm sorry, Newton into
Second.
Is it okay? So now suppose time interval is not small. Suppose it is large. Still we can have the concept of impulse. So how in that case what we do? We have this. We will calculate the total impulse by adding the impulse due to elementary time intervals. We have to take the total. So for elementary time interval, it will be F dt. You have to take the summation, vector sum. You have to take the vector sum. Is it clear? Alright. Now the other thing is that you may make use of average force. So if average force is available, so just take the average force and multiply by the total time interval. Suppose the total time interval is delta t, for which the force was acting. So just multiply the average force with the total time interval. You will get that. If instantaneous force is available as a function of time, you have to integrate. If force is in the, like here what you have to do, suppose force direction wise it is same. Direction wise it is same, then it is easy to integrate. But if it's not, then you have to be very careful because it's a vector summation. You have to vectorially sum up for every small time intervals. Okay, suppose let us say force is constant. Suppose force is a constant. Then it is very easy, it becomes very easy because impulse will be, since force is a constant, you have to add the time interval. Suppose when you add the small time interval, suppose you get the total time interval delta t. So this will be the answer. So if force is constant, it's not a problem. But when force changes, you have to be careful, you have to add them for every small time interval. We'll see those situations one by one. And if you have average force, then this the, okay? Now, suppose here it's in a special case, let us say that force is not varying in direction. Force is constant in direction. Direction wise it is constant. Only magnitude wise it is changing. Let us say magnitude wise it is a function of time. So if force is a function of time, we can denote the force by this. Force is a function of time. F of t means force is an expression of time, some expression. 2t square minus 5t, sin square t minus cos square t, 1 by t minus log t, anything, any practical thing. In such case, now we can simply integrate the elementary impulses. Is it okay? Suppose we are interested in the impulse from the instance t1 to t2. You have to accordingly integrate between the limits t1 and t2. You have to integrate this. And in basic maths you have studied integral y dx is the area below the curve integrated between x1 and x2. Basic maths, integral y dx integrated between limits x1 and x2 is the area below the curve. So that means here in the place of x you should have time, and in the place of force you should have, in the place of y axis you should have time, force. So if you have force function, the graph of force function as a time, and then you mark the time interval t1, erect a perpendicular to the x axis, again mark time interval t2, erect another perpendicular. So this area will give you the impulse, because this area is this and this impulse, isn't it? Regarding area you have to remember that area above the time axis is positive, but area below the time axis is negative. You have to be very, very careful here. Just as in displacement versus time graph or velocity versus time graph, area above the time axis is positive, area below the time axis is negative. So this you have to be careful. Okay? Copy this.